let's look at a GABA synapse. So GABA, again, is manufactured from a very commonly available amino acid. Only a small set of tweaks here are necessary to produce GABA. It's going to be packaged inside vesicles, like all our other neurotransmitters discussed so far. It'll be released upon arrival of an action potential. It'll enter the synaptic cleft and diffuse across that cleft, and it'll interact with receptors, both ionotropic receptors and also metabotropic receptors. Now, the ionotropic receptor GABA-A is particularly important in terms of as a site of drug action, and we'll discuss this, in a subsequent overhead. But basically, GABA will bind to this GABA-A ionotropic receptor. It'll shift its shape. It'll open a channel that will permit chloride ions to pass through. Chloride will enter, largely driven by the concentration gradient force. Remember that it's, you got a neuron here that's minus 65, and chloride is a negatively charged ion. So, the electrical force will oppose its entry, but concentration gradient force is strong because there's so little chloride in here. But chloride will come in, and it'll hyperpolarize and make an action potential less likely. So chloride ions enter through these GABA-A channels, right? These ionotropic receptors, and hyperpolarized neurons. Ionotropic GABA receptors mediate fast inhibition of neurotransmission.